Welcome to the Emergency Traffic Podcast. Hello, welcome again to the Emergency Traffic Podcast, where we discuss and review line of duty deaths of firefighters and paramedics to learn from these tragic episodes to hopefully prevent them from occurring again. We are doing another Tailboard Talk, one of our bonus episodes where we just talk about whatever's on our minds, assuming that we're sitting around the station yakking on the tailboard like firefighters do. Although tailboards are pretty short and small now. You used to be able to sit on them and comfortably fit a few people and some coffees and stuff like that. So I'm joined today by our new guest host, Denis, and our longtime traditional guest host, Dirk, for a Tailboard Talk. And today we're going to talk about technology versus tradition, if you will, in the fire services. So I've got a little outline here that we're going to have a battle about, a good discussion. Unfortunately, Doug couldn't make it today, which would have been great because he would definitely voice his opinion on some of these. But hopefully Denis will make up for Doug being absent. The first one I had on my list was, I should say, well, welcome, Denis. Hello, how you doing?
Thank you, Paul. Hi, Dirk. How are you?
Really well. Hi, guys.
Pleased to be here. Thank you.
It's always odd when we do a double header because we've already chatted for an hour, but that's good.
It makes it shorter then.
It makes it shorter. That's right. So the first one I had on my list, of course, was the electronic engine / pump governors versus pilot operated relief valves, the old school relief valve. So the electronic engines are all electronic now, so interface is easy. I remember the old engines, Denis might remember too, where they had a governor, but the engine was still manual. It was still a cable throttle, and they had all kinds of actuators and stuff. Fire Research pioneered the whole thing, and Waterous, I think, had one too, way back in the 90s, before the electronic engines, 80s, 70s.
I had two trucks from the 50s that had a precursor to the pilot-operated pressure relief valve. They were TIVOs.
50s? How old are you? Oh, ouch!
Sifinisa. They used vacuum brake cylinders to actuate the throttle, and you had a couple valves, and you played with the balance on that. And if you were within 25 pounds, you were doing well. That's if it worked at all.
Right.
But when they worked, they worked.
They worked well. And then eventually we ended up with the relief valve. So the throttle stayed constant. You picked a RPM that you wanted, and then the relief valve theoretically would sense the pressure going up on the discharge, and it would open a valve to dump water back to suction, back to intake, to control any pressure increases. The requirement to pass NFPA and ULC was, I believe, 30 psi or 30%, one of the two, I can't remember. It had to prevent that from occurring. Overpressuring one line, you close one line, the other one doesn't go too high. The problem, of course, is it doesn't add throttle. So you open more lines, you had to adjust the throttle again and reset the pressure.
The important thing is the operating principle there was discharge pressure. So it was looking at pressure. That's what it was looking at. Where new electronic governors don't look at pressure per se. They measure and look at flow rates. So that's...
Well, they're not really measuring the flow, though. They're sensing the pressure.
Some do.
We're setting the pressure in RPMs, right? Depending on pressure mode. We do have the flow meters, but we noticed that they're way off. Like they're not reliable. That's why we have to go with pressure. There's no way around it.
So most apparatus today have gone away from the throttle and the relief valve. There might be a few, but primarily we used to still get customers that asked for a relief valve and a throttle in addition to the electronic governor, which, okay, we can do it, but if the throttle breaks, it's going to the same sensor, to the same communication system that control the engine. So it's sort of redundant, but you do have a relief valve. So that's okay. What I'm finding now, though, is when you have trucks with electronic governors, as the engines change, the version of EPA, the Environmental Protection Act engine software changes, your governor becomes obsolete, and people are having trouble, cannot get governors for older trucks. the manufacturers don't make them anymore for an engine that's pre 2013 or 2010, and therefore they're having to get them rebuilt. Hopefully, with fingers crossed, the truck's out of service for 2 months while they're sending the governor away to the manufacturer to have it reprogrammed and new circuit board made or something, and then putting it in. So that's become a problem with aging trucks.
Remember back in the day when you used to have to buy a DDEC compatible governor, right? If you had a Detroit, for instance.
Right. And that's still the case. And now you have to have the engine version of the EPA standard. So that's becoming a problem. So are we better off than the throttle and the governor? The relief valve with the governor?
Well, the main issue with pressure relief valves was always that not maintained adequately and not exercised frequently. And then, of course, people not knowing how to use them. So those are always
easy now.
Yeah, I mean, like there's a screen on the pickup side where the water comes into the sensing bellows, if you will. And if you don't keep that screen clean, then it's not going to work properly. If the screen rots out and the dirt gets into the back of the governor, it's not going to work. If you don't cycle that governor, it's just a piston that moves back and forth. And if anybody's used an offboard relief valve, an outboard relief valve, it's all aluminum, they tend to corrode and get all jammed up, and so they don't work properly. So a lot of it is making sure you cycle it like every morning, right? When you're supposed to check the valves on the pump or whatever, you should be cycling the relief valve, but just turning the handle's not enough. You've got to pump it up and down, verify it's working. And in the wintertime, freeze-ups, of course. If you don't have an adequately heated pump house, you're going to have issues there. So there's lots of reasons why they will fail to work, but generally they fail to work because they've not been made to work on a regular basis.
I love teaching those because it gives the new pump operator a better understanding of how these things work. So it was great for teaching. And when we used to have the old, was it Pierce Hush pumps? Pierce?
No, E1. The Hushes were E1s.
The old
they probably
E1s
had relief valves on them, right?
Yeah, they had the relief valves on. Same with our Quints. And yeah, every day, right? The pump operator, pump checks every day. And it was exercised. So from a teaching perspective, I really like it. But I think with the new ones, the electronic governors, it's safer. I'm sure it's less prone to fail. And I wouldn't even notice if it fails or not because there's no light turning on. There's nothing saying, hey, the relief valve just opened up or something, right? It's just tries to keep the pressure at that spot, right?
Right. If the pressure doesn't maintain, then you know that it's not working right. The old initial ones were kind of clunky and didn't work very well, but now the newer electronic governors work quite easily. And the thing is they do protect the pump. If you cavitate, they'll shut down, and sometimes they'll even re-throttle up if you give it water because you open the hydrant or something.
Now the IC300s, the latest model that we have, goes through two phases. The first one would be like a low water alarm, and actually it throttles down for 7 seconds. Everything starts beeping, of course, and then it tries to get the pressure back up for 7 seconds and then throttles out. So you can hear when you're not at the pump panel, you will hear that thing going up and down, up and down. And then if there's really no water coming, it shuts down. But as soon as you fix the problem, it goes back up to the pressure you set. Some of the older fire commanders that we had, you had to go back to the pressure. I mean, it wasn't a big deal because you had to deal with that problem in the first place anyways. But yeah, I like them.
They do tend to. So I think we're agreed that the new governors are nice and probably the way to go.
Yeah, I agree with that.
The one thing is it does take the pump operator sort of tries to distance themselves a bit now because it's automatic, right? It's easy. Just press preset or set a pressure and then go do other stuff.
Yeah, funny story.
So one thing about that, what always bothered me is when I set my PRV on the old pumps, I usually did that for one hand line, right? My 700 kPa, 800 kPa, whatever you want to set it at. And the thinking is still, when I set this, it will protect my hand lines, like the electronic ones, but it won't. It will protect the highest pressure, not my hand line pressures, right? And I always thought, why don't we have something for the individual hand lines. If I set my pump discharge pressure at let's just say 1200, but I got two hand lines going at 800 and 950, they are not protected.
Right.
Right. I only protect the 1200 kPa. So I always thought that would it be possible to protect my hand lines, or do we actually want that? Is that a concern? Because I get water. They say you get a water hammer and it's going to damage the pump. Well, if I get the water hammer from the closing my 800 kPa hand line, but my pressure relief valve is set at 1200, it shouldn't affect it because the pressure is still higher than whatever I create with a water hammer.
The relief valve and the governor can't prevent water hammer. It's too fast. They don't react enough. They're supposed to try to control it, but I mean, if you have a line, or especially if it's more than 1.75" flowing, or a big flow line, and you shut it down, it's too fast. You're still going to get some water hammer, I think.
Okay. And is that a problem? Have you ever seen a pump that was damaged by a water hammer? Or are we actually just lying? Like it's one of those urban myths. We just teach it to everybody because we want to actually protect the hydrant system.
It's the infrastructure, I think, that's more the important part.
Yeah.
Denny, you were going to say something there. You started to say
I say funny story. I think it was around 2002. I bought the first automatic pressure generator, or a governor rather, on a pumper, and they were out at a fire, and I arrived anyways, and I couldn't find the pump operator. He wasn't at the truck, and I walked around the back, and he was sitting there on the tailboard watching the fire. And he says, "What are you doing?" He says, "Well, I'm not needed anymore."
Yeah. Well, I mean, that does lead to another one that I have in the list here, although I was leading up to it when I wrote the list. So because it takes several components. So without jumping ahead to that one about the pump operator doing other stuff, the next one I had was the electric discharge valves versus manually controlled discharge valves. What's our thought on those?
I like them. And I'll tell you why. Because I've had lots of manually controlled trucks where the valves are controlled by cables or levers, or linkages. And sometimes the valves are right at the panel and you can control them directly. Most commonly your auxiliary inlets, right? Your 2.5-inch inlets, 65s in my language. But as the efforts have been made to make the pump house smaller and to locate it differently, and like one company advertises their pump and pump house is basically underneath the tank and the body without naming names. Most of that is very, very difficult to accomplish with mechanical linkages. So they go to cables like Morse cables, and invariably cables become a problem because they get corroded and start to jam up. Sometimes the builders are not as thinking as far ahead as to make sure that those types of problems are not going to be there, or they cheat on some of the corners and stuff. And if you go for an electric, which is basically a fly-by-wire system with an electric motor that actuates the valves, you can basically put your controls anywheres. All you need to do is run a wire between the motor on the valve and the control. So it allows you some flexibility that way. The downside, of course, is that it's electric, and if something fails, it won't operate. But the downside of a linkage that binds is it doesn't operate. The downside of a push-pull cable is if it binds, it doesn't operate either. So you've got a lot of issues, and particularly with mechanical systems, the lever on the pump goes over center, right? So you've got very little leverage, a lot of leverage, and then very little leverage as it swings through the happy point. So you have to design your mechanical systems really well to avoid those problems. So you get into some of the other ones where they've got, sectors and screws to try to alleviate and have constant leverage, and there's a bunch of other mechanical systems. But I prefer I like the electric.
Bigger firefighter. If you can't move it, you just get a bigger firefighter.
Yes, I've seen that done it myself. Usually it's a shop job afterwards.
I've had trouble with the early electric valves. I was an early adopter, but we had lots of troubles because most of the early electric valves did not use a real position sensor. They used resistance to indicate open or closed.
That's a problem.
So if you had a jammed valve, because it didn't get exercised enough in a rural department or a smaller department, which I found is you had to exercise the valves on your weekly or daily checks to make sure they worked. And it would tell you the valves open, but it wouldn't be because it thought it was and it wasn't. So I don't think anybody does that anymore. Now they're actually realistic position
Limit
sensors.
stops.
They're better, and they actually sense when they are open or closed, so they give you a real thing. But the other problem is it's still electric motor, and if they fail, the manual override. Where is it? Can you get at it? And sometimes it's next to impossible to get at those.
But as Danny said, on the mechanical ones, unless you had like those old hush pumps where you can open the panel and then yank on it.
Reach in there, yeah.
But if you can't, then there's, as I said, then both fails, and it doesn't matter if it's electronic, electric, or a rod, push rod, whatever. It's not going to work. You just have to
Find
get
another outlet.
another discharge.
More points of failure though, because you've got the motor, the mechanics, and the controller, moisture,
And the firefighter.
wiring, and the firefighter. So
Hey, how come the hose in the hose bed's charged? I don't know.
that's because the chief.
That happens with both, though. That doesn't matter if it's electronic or mechanical. But the mechanical, same thing. You get all those linkages and all this.
Right.
It can break at any point. So really, as you said, Paul, like they got better. And I wasn't a big fan at the beginning, but talking to our mechanics and having the electronic valves now for good 12, 15 years, at least 15 years, all across the board. And seeing the different generations of electronic valves, yeah, absolutely. And to Dennis' point, there's like what I like, depending on what you need for your local needs, you can have the pump panel in the rear, facing rear, or have it on the back side, left or right side, depending where you want it. You can have them anywhere because
Pump cab,
right?
Because you're running a brush truck.
Yeah, or
Exactly,
I mean, we've done Regina. I sold Regina, I don't know, 6 or 8 top mount enclosed rear mount pumpers. So the pump panels in the cab. Victoria's got them too. Calgary has all top mount panels. I don't know if they have electric valves or not, but so it is nice that you can move them around. Edmonton, for some reason, has outside pump panels, the coldest city in Canada, maybe I think the most northern city in the world or something. But so it is nice that way. They are better. What I like actually is the hand wheel ones. So the small hand wheel, so it's not a linkage and it's not electric. It's a hand wheel. You can't do them everywhere, but those are nice. They take up a little more space on the
need
panel.
the valves close to the pump panel. Then everything has to go by the pump panel.
Right, in line.
Which you don't need it when you have electronic valves. Then you can put them wherever.
Yeah.
So two recommendations if you're going electric valves. Make sure, almost 2.5. When you specify the valves that are going to be on the pump, the mechanical valve itself, make sure that you're buying a high quality repairable valve, because there are some out there that are not, that have a history of malfunctions and difficulty to repair. And that also goes with the motor itself. Make sure it's a quality unit. Secondly, most of those have grease nipples on them. And because one of the reasons you're putting your electric controls in is because you're tending to compact your pump house as much as possible, which means getting in to service that tank to pump valve or some other, maybe you're discharged to one of your pre-connects above. It's hard to get to the valve. So what I used to specify was an extension tube on the grease nipple out to a panel where every one of the valves came together. There was a grease nipple in a panel, easily accessible, usually on the offboard side. So you could grease every one of your valves remotely. You got to exercise them, of course, and Dirk's already talked about that. But the other thing is some of your key valves, like your master intake valves on the inlets and so forth. Sorry, jumping ahead in the script here, Paul. But those ones should have manual overrides. And I would suggest your tank to pump valve and your 2 intakes should definitely, left side, right side, should definitely have overrides on them. And usually that's a little hand wheel that you turn. And if you can't get the override directly coming through the pump house panel, have a little door that you can reach in and get to it. Because those things are mission shutdown valves. If you can't get the valve open, you're out, you're done. So it's not as important if discharge number 9 is not working. You can always go to discharge number 8. But if you can't get the water into the truck, you're basically not getting it off the truck. So those are just some pointers in my mind.
Speaking of those internal intake valves, or those master intake valves, the 6-inch, the steamers. Personally, I don't like the ones that are behind the panel. Okay, because one, they're a butterfly, and a butterfly valve is inherently failure prone because you've got that large sealing surface versus a ball valve, which is typically less failure prone. But the problem is if it's behind the panel and that valve fails, open or closed, it renders the truck almost out of service. If you have two, hopefully you got one on the other side. And I don't know how many fire hydrants I've had where they have internal intake valves, they have an adapter on the intake, and they depend on that. And they don't even keep the 6-inch cap. So I can't take it out of service by simply putting a cap on it. I like the ones that are outside of the panel. They can be remote controlled. That's not a problem. And they have a manual override right on them. But at least it's not tucked in behind where it takes the truck out of service when that valve decides to leak a bit or not close or not open.
A couple of reasons why I prefer the MIV versus the offboard.
That's because you like hail.
So
who doesn't, Paul? Who doesn't?
Waterous, Darley.
Darley.
Okay, I thought we weren't going to talk brand names, but never mind.
Doesn't matter. We don't get any sponsors.
There's only 3 anyways, isn't there?
Well, U.S. Fire Pump is coming along now a little bit.
The reason I like them is that I take your point about the failure of the MIV and how difficult it is to overcome a failure like that. You have auxiliary inlets. Have a plan for using those if you have to. So there's ways around the MIV. You can use one of your 2.5-inch or 3-inch auxiliary inlets as an alternative. But for all the vehicles, all the pumpers I've had with outboard valves and all the ones I've had with MIVs, I would say 2 or 3 times to 1 ratio of failures of the externals, usually due to corrosion.
Cheap externals.
That would be the reason. Absolutely.
Yeah. You got to buy the Akron's got the big ring on it.
I have some Scotch blood in me.
And that other one is the TFT, the big ball valve. Those are nice.
I've tried them all, and trust me, not every one of them is reliable. They're not.
It's the fire truck. Nothing's reliable.
Nothing's reliable. So the other thing, they get in the way of enclosing your pump house.
They can, although when you buy the truck, you have to specify this valve will be on there and the door must close. I've done that, and the suppliers do go nuts over it. But
it's difficult because some of them are really deep, and it interferes with your ability to hook hard hose up because you've actually got to take that valve off to do suction with it. Usually,
no, you don't.
Because
why?
Because it's only got a 4-inch discharge on it or whatever.
What? No.
It can affect how you use.
You buy the appropriately sized valve and you buy suction hose with that same size Stort's fitting. Just make sure you got the right gasket on the valve.
I spec a truck so the offside doesn't have a cap. It has a 5-inch Stort's connection on it, and on the driver's side is where you hook your hard hose to. So you can either.
Don't tell me you're using threaded hard hose. Stort's.
We were. Lightweight. Well, the problem with Stort's is on suction is you have to make sure you've got the special gaskets in, and they can.
It comes with the hose. You just have to change the one on the truck.
That's right. So it makes it more
difficult.
Difficult.
When you buy the valve, the cap that comes with it, it's got the suction gasket on there. You just switch them. It's easy.
Yeah.
So,
if you don't forget it, it's easy. Yes.
Yeah. What's drafting anyway?
I can't. I'm sucking air. I don't know where it's coming from.
I'm in Calgary. We don't draft. Sorry.
Yeah.
But Edmonton does.
You don't have water. What are you talking about?
Edmonton carries hard suction hose, just like New York City and San Francisco.
And it's threaded and goes to the steamer port on the pump panel side. Yeah. But we also practice on the other side. We have a piston intake relief valve on the.
They mean in this city in northern Alberta that.
Yeah. My city. Yeah, exactly.
Oops.
Best hockey team in the world. There you
right
go.
On. Yay, I like it.
Don't have to edit that.
So speaking of electronic governors, electric valves, and remotely controlled intake valves. The next big question, and this is the one that's current and today, what about the next generation electronic governors with integrated valve operation? So automated pump operation. So you hit the button, you want water on discharge one or whatever, and it automatically opens tank, throttles up. When you give it hydrant water, it openly automatically opens your intake valve. You add a line, it adjusts it all. The popular name out there right now, I believe, is by Hale. It's called the SAM, or IDEX Corporation. Uh, Personally, to me, it's too much electronics, too much stuff to depend on. I'm personally not a fan, but they are gaining, it does make it easy for training pump operators and seamless operation. What's our thoughts?
You still have to train them so they understand how the system works. They still have to be able to troubleshoot. But if you have everything under your control, you're the pump operator, you're opening and closing all the valves, this is where you troubleshoot. If the computer doesn't open a valve, where do I start? Like can I still troubleshoot that? I'm not sure. So
Yeah, usually they
I'd say
still have
right
an
now,
electronic valve controller.
same as those electronic valves. I say right now, probably in its infancy. So probably stay away till somebody else tries it out and it gets better.
Now, I don't know if you have to buy Hale or Class 1, like a certain brand of valve to go with that controller. That's sometimes manufacturers kind of set us up there. You can't have an Acron or an Elkhart because you have this controller. I'm not sure on that. I have to check, but
My,
that
my, my suspicion is that the departments that are interested in actually exploring that avenue are departments that think they have a need for it, and the need is driven by experience at poor operations.
staffing.
And
Yeah.
it's a staffing issue, it's a training issue, it's an experience issue. I think that's probably what's driving the interest in that, is that they have lots of people who can drive the truck, relatively speaking, because it's an automatic. It's just a big Honda Civic.
Anybody can drive it. It's a big.
That's what they think. I know, I get that.
Yeah,
Don't get me started on that subject.
I know.
And and pump operations at the scene is poor, and they've had some problems where guys have lost suction and lost water supply, and they've have overpressured or more likely underpressured attack lines and so forth. And they're looking for a solution, and the solution is not train enough people and certify them in pump operations, because for whatever reason they don't feel, or their experiences is that they cannot accomplish that. And so they're looking for a U drive or a automatic. If the truck drove itself to the scene, they'd be happy with that too. They're looking for that type of an approach whereby the truck does all the thinking. We don't have to train our people to do that. And I think fundamentally there's a flaw at the bottom of that thinking, and the flaw is exactly where Dirk put his finger on it. It says, if you don't intimately know what's going on because you've been well trained and well experienced, when something doesn't go as planned, what do? Who are you going to lean on to fix the problem when the world's on fire and that's your frontline pump? And in a rural situation, that's the only pump that's down the driveway. Everything else is out on the street. How do you fix that problem?
And how would you feel when you go inside and the hose line you're having in your hands is relying on the computer, right? So yeah, I'm totally with you there. I think it might happen down the road, but I think the solution to the lack of training is, especially in career departments, have an engineer, have guys that do nothing else than driving the rig and operating it, and then you have a smaller group you can update on training. It would make things so much easier. But at the same time, I know chiefs have a big problem with specialties because they are hard to schedule. They are not round pegs, because round pegs are easier, just plug and play, and everybody can do everything. But if you want to alleviate these problems, I think you need a
Yeah.
designated driver, right?
Yeah. In my experience, the problem with getting designated drivers was more establishing another level of authority is not the right word, but you got your fourth class, third class, second class, first class, and then you're into another officer type level So you're adding another step on the rung for promotion, and not everybody is going to be accepted to take that. It's not a promotion based on number of years of service. It's going to have to be based on demonstrated skills and ability. And the problem there is in a lot of collective agreements, any promotion that's not based on seniority is a problem.
Yeah.
And so if you're just cycling people automatically through the chauffeur's position, the engineer's position, because they're the next guy up with 15 years,
You got the same
you
problem.
haven't solved the problem. All
Yeah.
you've done is pay some guy 13% more. That's
Yeah.
all you've done. So,
Yeah.
and I ran into this when I wanted an aerial operator, because in the last department I was in, every senior firefighter who was certified as a pump operator basically cycled through the aerial operator position depending what shift he was on and who was available. So as a result, you got some good operators some days, and you got some not so good operators the next days. And I wholeheartedly agree. You should have a specialty position for that, but making it happen is
It's difficult.
requires
Yeah.
basing it on skills
Yeah.
as opposed to seniority.
Yeah.
And
There's
that's where
collective
the catch
agreements,
is.
there's unions and stuff. I think that the best solution would be kind of like the specialties, hazmat, TR. You just volunteer for it, and that's it. You get trained for that. There's no pay increase. There's nothing, and the problem would be the skills testing, because we're struggling with that in the specialties as well. Like some guys just want to, just they want the cape that everybody says in TR, right? They want the cape, and other guys want their, I don't know, they want fancy rooms at home. That's why they joined the hazmat team. But there's really no skills testing requirement there, and then again, that's a union problem too. Like, what do you do with guys that don't perform? Do you kick them out? Right?
Well, it's a question
Which,
on your culture.
Yeah.
there we go.
What?
We're going into another podcast.
Aren't
Absolutely.
we though?
Absolutely.
Yep,
Yeah.
leadership, management, culture. We'll do
Yeah.
another tailboard on that. Back
There's
to
there's a lot to talk
electronics
about there.
system. Yeah, back to electronic systems and stuff. And you mentioned it. You led right into it there. Denny was the operating the aerial operator. So the next one I had on my list was, so what do we think about sophisticated aerial operating systems versus manually controlled aerials? So examples are smart aerials, which typically is understood as envelope limiting. Okay, so they sense where the jacks are, or they sense the load in the basket in the European designed ones, and they let it go out to a certain point. So I know, like the Rosenbauer Smart Aerial, the North American one, you can just put the jacks down. You can lift the aerial full extension, and you can rotate it all the way around, but only in a limited envelope. You have to be fairly high elevated. Or you can work off the front, like 10 degrees either side of center, full extension, full load, or off the rear, full extension, 10 degrees off center. So these smart controls versus non-smart, which have no limits. So you take your basic E1 aerial. Most actually North American aerials will go full load at 0 degrees, 360 degrees around the truck. They don't sense the load in the basket. They usually sense if the jacks are out, so they know. What do we think about those?
I'm conflicted.
There you
Because
go.
you know what I'm going to say? It all comes back to OPs and training
Right,
skills.
right. The smart aerials sometimes require more maintenance or operators to understand. I mean, if you look at an articulated aerial such as a Bronto or a T-Rex, the Rosenbauer model, a lot of the problems my experience shows is it's often blamed on technology, but half the time it's operator error. Why won't it let me do that? Why won't it let me do that? How come I can't turn this way? How come I can't do this? And it's a sensor telling them that, dummy, you forgot to turn the cage, or hey, you forgot to do this, or you got to press this button to do that. And so it goes back to operators again. The European aerials, almost all of them are smart. They sense even a Bronto or a T-Rex senses the load or the amount of extension, and they limit your extension based on the elevation that you're on. Some of them more so, they sense actually the load. So yeah.
They sense everything, and that's not even like we like to say it's a modern thing or it's an advancement in technology. I started with the career department in '97, and they already had computer controlled aerial devices that did everything. You still need an operator to put the outriggers out and stuff like that, but really, it's a totally different system than the North American system. And it's funny that some want these, what we call the SAM system, everything electronic for the water, but I don't want to go electronics on aerial devices. Like, I
Uh,
don't understand that, right?
and Denny might remember, but actually Tebow, which was a Canadian company that built aerials, were famous. They eventually sort of went under. They've been reborn several times, but their aerials, they were early adopters of the European technology, having electronic over hydraulic controls for their aerials. But they were absolutely wrought with problems due to one, voltage. A big problem in North America for electronic controls is that we typically run on 12 volts. And on an aerial ladder that has 100 and some feet of wiring, 300 feet of wiring on a 100-foot aerial, because it extends 3 sections to 100 feet, so there's 300 feet of wire, you lose voltage. And therefore sensors malfunction. And also our maintenance standards in North America aren't nearly what they are in Europe for fire equipment. If I take the SCBA, for example, in Europe, it's fairly common that any time an SCBA is used at a fire, that SCBA is then recertified by an SCBA technician. They do a flow test, they do an inspection, performance test. In North America, you're hard pressed to make sure departments do that once a year for the BA. That's the tradition in North America, is once a year. Where in Europe, every time it's used in anger, it goes through that. We're the same with ladders. We don't do the maintenance. We expect them to operate. So is that part of I think that's why the sophisticated control systems were not in favor in the 80s and the 90s. The Brontos were the first one that brought that commonly in North America in the 90s. And the problem they had, of course, was we converted them to 12 volts. And then, of course, the micro switches didn't sense the right power and all that kind of stuff. And they need different maintenance. Some cities were successful with them, some weren't. So it's kind of interesting. But now we're going that way. E1 was sort of the last holdout, I think, with the direct hydraulic controls. And you press out and it goes out, and you press in and it goes in, and it doesn't. That's why they're so beefy, is because they have to be able to carry the full load at full extension, versus a European aerial, which is envelope limiting. It doesn't take the full load at zero to full extension.
So two quick stories. One, we were operating a mid-mount at a large fire, and it was on asphalt, and it was operating over the side and fairly low elevation, but fairly far out. So it was a platform. It was loaded heavily. So that outrigger, the mid-mount outrigger, which is pretty much below the turntable, a little bit ahead of it, it punched through the paving because there was a drain under there, a couple feet down, which collapsed. So it punched through and unloaded that. And if that aerial had been smart enough, it would have right away known that it was unsupported. But as it was, we noticed it right away because the truck did a little. And so they went and checked and, anyway, repositioned, whatever. So, but a smart aerial would have known right away and told us that issue had happened. And this was in the middle of the night.
But it would have stopped, and the operator would have had to understood why it stopped.
Correct.
That's
not
the
just
problem.
Push the override button.
Right. Yeah. A lot of the modern aerials today have load senses and all the feet.
Yes.
All
Stop here unless you don't want to.
And all of a sudden you'll get an alarm. Well, why am I getting an alarm? I don't understand. It won't let me extend. Well, no, it's going into the worst, so you can't extend. You can retract, you can rotate, and you need to reset, right? And then the operators go, what's wrong with this stupid truck? Send it back to the shop.
Yeah. So that's story one, where a smart aerial is a good thing. Of course, I remember from the early 90s, I remember a company by the name of Nova Quintet.
Which is a disciple of Tebow to a certain extent.
Yeah, and they came. A neighboring city had a 100-foot straight stick, and they came to demonstrate it to us, except that it didn't work, and it jammed, I think, with the aerial partway up. So I remember them opening the door in the back where all the I forget the programmable cards. What the hell are they called?
Yep, they were little cards, and you jiggle a card and it would work again.
Yeah. So the guy was there, pulling cards and switching them around. It was like an episode of Star Trek,
Yeah.
where they're moving all these little things around, got the thing bedded and drove it home. I think the thing had a common issue with that, and it was corrosion or whatever the problem was, or voltage problems or whatever. So for a lot of us looking at that and compared that to the old manual thing, we thought better with the smart firefighter.
Yeah.
So my thoughts on that, I'm a big fan of the European aerials, but I'm biased.
A little
for
bit.
obvious reasons. But here's the thing, and Doug is he's the traditionalist in this, and he loves his tiller truck and all this stuff. But fundamentally, Europeans use their aerial devices for different reasons. They are primarily your secondary escape route in all those buildings that don't have a second stairwell, which is almost all of them, right? So all this truck does, and the fire department has to purchase one once the buildings are taller than whatever floors. They have to, even the smallest volunteer departments, sometimes they have an aerial, and they're just like, why would they need this? It's like, well, that's your secondary means of escape. That's the primary reason. There's usually two, so a driver officer, maybe a third guy, but rarely. And there's almost no compartment space on it. They're super light. They have to be light to adhere to building codes. So a totally different tactical application. Here, we want the jack of all trades. It's basically a pumper truck with an aerial on top of it, right? So say it, Paul, say it.
In your city, they're a jack of all trades, but not everybody's doing that.
In a lot of Canadian cities, it is that way. In a lot of Canadian cities, we just talked about this.
Montreal,
we don't have truck
Winnipeg.
operations. We have firefighters on that truck, and they are assigned by your instant commander. No pre-assignments needed because I just need these crews to do this and that, right? So again, fundamentally very different. In Europe, not an aerial, like the only time aerial goes up by itself is when the storm hits and there's trees and there's shingles flying all over the place. That's when they're more needed than ambulances. For the rest, they always respond as a unit with an engine and a tanker. Because
Calgary just bought,
right?
Calgary just bought 6 no pump aerials. They're going back to what they were before, which is
because
why do we put
in Europe that's normal because you send a tanker truck that's going to pump that aerial, right? And they practice this, and this is the standard operation. It's very, very different than North America. That's why I like to argue, but I really can't because it's just you can't compare apples with oranges. That's my take on it.
If you're going to have an aerial without a pump, you need 2 pumpers. One at the aerial and one at the hydrant.
Yeah.
Unless you're all sitting on top of the hydrant.
Oh, yeah. If you're like Edmonton, they do industrial hydrant spacing everywhere. So they're all like 150 or max 300 feet apart.
90 meters in industrial, 150 residential,
Yeah, the whole city.
But when Edmonton was still, cows with big horns running around, all furry ones, otherwise known as buffalo. In my city that I was last in, the pipes were already 100 years old in the ground.
Right. Yeah, exactly.
And if you put more than 60 pounds in them, you didn't have to worry about getting the hydrant. You just started thinking about which part of the street you were going to draft from because you'd break everything.
So we think the sophisticated operating systems have a place as long as they're reliable.
Yeah.
And
training operators.
Application. It's like everything else in the fire department. There is no magic silver bullet.
Okay, so training operators. Here we go. This is the pièce de résistance of my list here today. Master stream on an aerial device.
I got a story for you.
Okay. So I have an aerial device, and everybody says, why the hell do they put a fog nozzle on the end of an aerial device when you can't use the fog usually? It should be a smoothbore. And I always come back with, yes, smoothbore would be the ideal nozzle, except that typically, if you're flowing master streams, you either have one of two problems. You have not enough water to supply the master stream, or you have lots of water and you forget to take the small tip off the ladder. So that's why you put an automatic there, because if you forget to take the small tip off to flow lots of water, it will open. It will adjust to the water you can give it in straight stream, but it will automatically adjust. Most of them are 70 psi nozzles now, so you only have to show them 75 psi or so. They're fully open. They're flowing your 4,000 or 5,000 liters a minute, whatever they're designed for. Yes, the smoothbore is better, but the smoothbore requires someone goes up there and spins off the right tip, and you have to know how much water you have before you do that, which you don't. So,
okay, then you go first.
Listen, I was a proponent of automatic nozzles. I bought a lot of them in the 80s when they first came out and they first became the thing.
I'm not talking hand lines here. I'm talking a ladder.
And it was hand lines, and I had them on deck guns and different places. But I've since learned the error of my ways.
I agree for hand lines. I used to sell them too.
So the main thing is to get enough water on the fire. And I can tell you more than one example, but I'll give you one specific example. And Paul, I already shared this with you once before. We had a fire in a 3.5-story Victorian, and it was in the upstairs area, and it was burning heavily up into the attic, not a cockloft. It was a peaked attic, and there were dormers and lots of issues. And the aerial was sitting there with an automatic nozzle on it, and was pumping a really nice stream, and it was just kind of, doing what happens when you pour water on a roof, running off. And anyway, the fire wasn't going out, and there were no big storefront windows that we should have been putting the water through, so that wasn't an option. So the only way in was basically in through the dormers from the roof. And after 20 minutes of that, I had a discussion with the IC about, we're just messing with this thing. Get that stick down, put the smoothbore tips on, put a truck on the hydrant, and pump this thing. And 5 minutes with the smoothbore, we had the shingles off, we had the roof boards off, and we had a heavy straight stream right on the fire, and it was out.
But it's not the smoothbore that did it. It's the fact that you flowed enough water through the nozzle.
That's right, because with the automatic, we had no clue what we were flowing.
There's a flow meter on the panel. It tells you.
It looked beautiful. Not on this
operator
truck.
Training. There's a flow meter right
truck.
there. It's required. Every NFPA, you have to have a flow meter on an area with an automatic nozzle.
Yeah.
So my take on this is, how do you know that your 4,000, 5,000, 8,000 liters are enough to beat the BTUs in that fire?
Well, there's that.
I like to argue it's not the amount of water I'm putting in there, is where I put it. Right. And most of the time when the towers go up, you said it before, the crews come out and the building goes down. And we're washing roofs because we wait for the fire to burn through so we can put the water through attics, all this stuff. And all we do is we flood basements.
That has nothing to do with the nozzle.
It has nothing to do with the nozzle. It has everything to do with the application. But same as the hand line, we usually run too low of a pressure. We're rarely too high.
Yep.
And we rarely don't have enough water for the fire. We usually don't have we don't have enough. We rarely have too much. I don't think that's the thing, like too much water. So even if I have my smoothbore tip, 1-inch smoothbore tip, and I get 2,000, that's called 2,000 liters a minute. Who cares? If I have 8,000 or 2,000 and I don't hit it in the right spot, it doesn't matter. It makes no difference. So I'm better off starting on the lower end because I have to set up my relay operations. It will take time. If I have 2,000 liter tip, I can run it off the tanks. The first engine, I give the tank water, use the tiny tank on the aerial. I get 4 or 5 minutes of a good solid stream. If I put it in the right spot, I make more of a dent on the fire than having to wait till I have my 8,000 liters a minute and the relay is a gong show and all these problems. So I like to start with the smoothbore and the fog. I will, except for hazmat, we'll have the fog right next to it. I can switch it up, right?
What he said.
Yeah, well, in E1 typically they always sold it with a fog nozzle standard, but it was cabled to the aerial so that you could easily just spin it off and throw the tips on there.
Yeah, we had a little box up on top, and we kept
Right.
the
So
fog in the
my
box
problem
where it
is
belonged.
my problem is this is the way the truck came. It came with a staggered tip in the bucket and the fog attached to it. Now I go because we do the research, we're talking about the problems we have. It's like, well, let's just switch it up. No big deal. Well, I switch it up for the shift. I come back the next shift. Guess what happened?
Well, you
Well,
have to
that's where you
educate.
order.
Who the F? Yeah, I'm beeping for you. Who the F put that smoothbore on there? And what happened? And it's like, well, why? They had no argument other than this is the way the truck came.
Well,
It's like,
that's
well,
why you.
no,
That's
in
why
fact,
you.
the truck came with no hose. And we put hose on it. Right?
That's why
It
you
came
order those trucks
cooled,
with two
and we put
monitors.
hose on it. So,
Yeah, I had a truck. My
Two
last
monitors
boat,
because you can't make up your mind.
the last truck had two monitors. It was sold to them as a industrial, if you will,
Yeah,
2,000 gallon
yeah.
minute aerial or
Or a
something.
suction.
No, it wasn't.
No,
It was a Smeal. John Witt. He doesn't listen. If he does, he'll
right.
call me. And it was sold. It was sold as an industrial kind of pumper. So they added the extra monitor,
Right.
and it had two automatics on it. The problem is the waterway wasn't any bigger when you added two monitors. It was just. It's a good idea to have two monitors. Are nice. Don't get me wrong. You can fight the fire here and you can cover the exposure there. Awesome, great. But every time we took it out and we practiced with it,
You got problems.
as soon as you open one, it's great. You open the other monitor, we can't pump it enough. We can't get the water up the waterway. So that truck, what I did is I bought a set of stacked tips for the one monitor, and I said, use this one first. The one with the automatic on it, that's your buffer. That's your, when you have a little extra water, you use the automatic. It's going to look good. It's going to flow good. It'll have the same reach. It just
Good
won't
for
have as much water in it.
good for exposures.
Yeah, good for exposure. But
so
the big problem with aerials is don't put it above the frickin' building. Put it. It's your arm. It's a quick setup master preview. Put it through the front windows. There was a city here in Alberta that had a fire last week in a sex store or something like that, burning, and had all these nice big windows in the front, and they were out. And where's the ladders? Way up in the air, spraying the roof. Going, what for? Like,
Well, you
put
want
them
to keep
through the
those
front
shingles
window.
wet.
there were no
Uh,
shingles on that one. And that department's defense, and I might know the department or not. We do have 65 quick attacks, and they're all in the windows. So there was water flowing in. The problem was there's a lot of compartmentalization, which is very unusual for a commercial. So they had a tough time
right.
hitting the water from
Now,
the top, from the bottom. But we all agree, and it's not a Northern Alberta big city problem. It's not a Southern Alberta big city
it's
problem.
everybody. It's
It's a
everybody.
worldwide. You can look.
It is.
You
Yes.
go to
It
China
is.
and you
There
go
was,
to Thailand
yeah,
and you go to Australia, and everybody does the same thing. The towers go up, and they're just washing the roofs till the fire burns through.
Yes.
yeah.
Yeah.
But there's a big difference
Done it
between
myself.
that 65 quick attack, which we delude ourselves to think that's a monitor. It's only at maximum 2,000 liters a minute if it's a good one. There's three brands out there, and some of them don't flow a lot, and it might have an automatic on the stupid thing. Uh, you know, Whereas the monitor on the aerial is easy 4,000 liters a minute. You could probably push 5 or 6
Yes,
if you're down
absolutely.
low and you open the throttle, right? There's a relief valve at the bottom. It won't let you overpressure. It'll protect it to a certain extent. So you're diluting yourself by setting those quick attacks up versus taking the ladder, punching it straight out, and opening those nozzles and letting it rip.
That's
And
already
going.
two steps further than we all agreed on. Residential tactics for commercial
There you
buildings.
go.
What is
There
the
you go.
first line you pulled? It's the inch and three quarters
Yeah,
every time. And there
yeah.
is like, why the hell? So they put up 65s. I'm happy. That's
Well,
already better than
small step, baby
than the
step,
small stuff because that really doesn't do anything, right?
baby
Put
steps.
put the fire out. Go home for breakfast.
There you go.
Yeah.
Okay, guys, that was a great tailboard talk. Unless anybody's got any burning issues, that was fun. Even
No,
without
that was
Doug,
fun.
I
Yeah.
think we managed to have a good time. So we'll see. Thank you very much for listening to another episode of the Emergency Traffic Podcast and this good Tailboard Talk discussion. Give us a like, give us a thumbs up, and we'll talk to you for the next one.
And I'll do it this time. See you at the big one.
Denis is speechless. No last words.
It's hard to beat that.
Hard to beat that. Okay, for your
Salut.
inaugural appearance. Salut.